Hello everyone, good day and welcome to academyx.co. It's Tutamarachi here, and we'll be taking you on carbohydrates. Recall that in our previous contacts, we dealt with introduction to biochemistry, lipids, introduction to lipids in biochemistry. This time around, we'll be dealing with carbohydrates, a very important class that I'm very sure you must have had for breakfast or you will still have today in your meals. So, to just get straight into business, carbohydrates are, I'm just going to read what I have on the screen and then explain further so that we can get to it. But in this course, in this particular module, what we'll be dealing with is understanding by carbohydrates at a molecular level, also understanding this classification, structure, function, and application in biochemistry at large. So carbohydrates are or could be defined as polyhydroxyl aldehydes or ketones or any of these substances that yield one of these compounds on hydrolysis. Now, I'm very sure the text they look big, especially for people who are just coming into people who need their pre-med or people who are learning biochemistry newly. It's not hard. Trust me, it's not hard at all. You just simply know that big words are from small words. And so we're going to break down all the big words that we have in that text and then to help you to understand what carbohydrates are. Normally in primary school or in high school, they will just teach you that carbohydrates are hydrates of carbon, having carbon, hydrogen, and oxygen. But this time around, there is a pattern and there is an understanding chemically of what carbohydrates are, and we're about to discuss that in detail. So when you hear the word polyhydroxyl, it just simply means poly plus hydroxyl. It just basically means a lot of hydroxyl groups, a number of them of hydroxyl groups, and these are hydroxyl groups here. And then it said polyhydroxyl ketones or aldehydes. When you talk about ketones or aldehydes, you're talking about a class of carbonyl compounds. If you remember organic chemistry very well, carbonyl compounds that deviate or are differentiated by the other atom that is bound to the anomeric carbon. Anomeric carbon is simply, or carbonyl carbon, is the carbon that contains the oxygen, the bond, the double bond to the oxygen group. So this is the anomeric, the carbonyl carbon. This is also the carbonyl carbon. But then, what differentiates or what separates a ketone from an aldehyde is the other atom that is attached to the carbon. Now, for ketones, usually it's an R, and R usually signifies an alkyl group. An alkyl group could be, methyl, ethyl, methyl is CH3, ethyl is C2H5. If you remember organic chemistry very very well. So these are an amol, methyl, ethyl, propyl, butyl, as much as you can have. R could be as long as very very long self. So you have this for ketones. It just simply means that the carbon is just simply double bonded to the R and then the rest of the chain. And then for aldehydes, the carbon is bonded to a hydrogen here and then also the oxygen as well. And then you have this rest of this chain. And in this rest of this chain, it could be like other carbons that the OH, that is the hydroxyl groups, could now be attached to. So you could have a number of the hydroxyl groups attached to the carbons, attached to the carbon. We're going to see that, don't worry. And this is what makes for carbohydrates according to their chemical structure. We're going to draw it so that it will become easy to understand. But just know it that carbohydrates are polyhydroxyl aldehydes or ketones or any of such compounds that yield or any of such that are yielded on hydrolysis. See, or any of such or any of such substances that yield one of these compounds on hydrolysis. Why we are saying this is because you will come to realize in the classification that there are bigger carbohydrates, there are smaller carbohydrates. So even the bigger carbohydrates on hydrolysis will still yield these smaller carbohydrates that still have these polyhydroxyl aldehydes and ketones. And for that reason, they are still classified as carbohydrates. You will not call them something else. Just like when we dealt with lipids and we said we have simple, derived, and simple, complex, and derived. We said that for those derived lipids, usually the derived lipids could be gotten from the hydrolysis of maybe the simple or the complex lipid. So just because it is broken down, just because it's a product of its breakdown, it is still classified as such biomolecule. Likewise, in the case of lipids, and also now in the case of carbohydrates. Now, carbohydrates are actually the most abundant biomolecules. They're actually more abundant than the lipids, fun fact. Distributed widely in plants, animals, microorganisms, where they perform both structural and functional roles. They are hydrated carbon molecules. This is like the simplest definition of carbohydrates. They are hydrated carbon molecules. Generally, the hydrogen and oxygen will be present in the proportion of 2:1. So for every oxygen, for every one molecule of oxygen that is present, there will be two molecules of hydrogen present in the carbohydrate. And then many carbohydrates have the empirical formula CH2ON. So that's where we get the hydrate of carbon. CH2ON. Sorry. Oh, sorry. CH2ON. So like H2 obviously, like we know, is water. I just did this to just show you that this is water, but like the N value actually covers for everything. So H2O meaning water. So water or hydrate majorly. Anyone, whether you call it water. Water is like layman English. Hydrate is, chemical semantic. And then hydrate of carbon with an N, because N could range from 1 to like thousands, where 1 is like a simple carbohydrate, and then a thousands or 2,000s or 3,000, 4,000 become those polysaccharide carbohydrates. So let's get to it. Some carbohydrates also contain nitrogen, phosphorus, sulfur, because it's carbon. Like we said now, even when we dealt with lipids, carbon doesn't only bind to like oxygen and hydrogen. It can still bind to like other elements in the periodic table. So for that reason, there could be like additional bonds of phosphorus, nitrogen, sulfur, in addition. But then usually this type of like carbohydrates are very, very specialized and like have specific uses. They are not really classified under the normal carbohydrates. They have like extra or additional classification for these ones. And then the biological like importance, or basically like the functions of the carbohydrate. I'm going to get to the structure. We're doing the functions now because the functions is actually more easier to understand than the structure, but very easy to understand. So now, going to the biological importance of carbohydrates, CHOs, what have you. So carbohydrates provide the majority of energy in most organisms. They are also the most abundant dietary source of energy for all organisms. Now, energy for immediate use is provided by carbohydrates. It doesn't mean that the lipids or the other biomolecules do not provide energy. But like I said, energy for immediate use, that is energy that is used for like action, motion, like movement, other type of activities, basically, is provided by carbohydrates. Lipids provide energy, but then usually it is like storage energy, and that is like reserve energy for use when like there is no like carbohydrates present. So like first line of action for energy, carbohydrates, then second line, lipids, if you understand. And then so in animals, glucose itself is stored as glycogen in the liver and in the muscles. So that's the reason why, okay, let's bring it down to like real life. That's the reason why if you eat too much, like, or if you eat basically, yeah, you will notice that like gets bigger immediately, or like very noticeably, is like the stomach area. What we call the stomach area actually is the abdominal area, and it's because the liver is like heavily present in that area. So the glucose that is being like taken, ingested, is now converted to what? Glycogen. Glucose is like the building block, like tiny, it's like the amino acids, and then it is now coupled together to now form what is called a large carbohydrate called glycogen, and it is stored there in the liver and also in the muscles. Liver primarily, muscles next. So carbohydrates also serve as the storage form of energy to meet the immediate, like I said now, immediate energy demands of the body. Then carbohydrates also, like cellulose, give structure to cell walls in plants and membranes. If you remember very clearly, the plant cell structure is very, very fixed, very, very defined. Unlike the animal cell structure that is very variable, very variable, like it can take different shapes. What gives the plant cell wall that structure? The plant has a cell wall which animal lacks. The animal cell lacks. What gives that? What forms the element of the cell wall in plant, which still gives it that structure and form, is called cellulose. And cellulose is also like a polymer, also a type of like carbohydrate that is a polymer. And in the coming slides, we'll come to see what cellulose looks like and what it is what it is made up of basically. And then carbohydrates serve as metabolic like intermediates. Example, glucose 6-phosphate, fructose 1,6 biphosphate. These metabolic intermediates derived from glucose are used for the biosynthesis of amino acids, nucleic acids, and nucleotides. Basically, the human body, or not just the human body, living organisms have like warehouses, like you usually manufacture everything you need. So you will take in glucose, or plants will take in, glucose into their body, not into their body, but like into the cell structure. But then it doesn't end as glucose. Glucose is the starting material to get a lot of things. And so from glucose, you need to get intermediates that are useful in making other products. So now some of these intermediates include now this glucose 6-phosphate, fructose 1,6 biphosphate. It is needed for the release, breakdown of energy, everything. And carbohydrates is very majorly highly valuable and useful in the production of like this metabolic intermediates. Next, carbohydrates like ribose, deoxyribose comprise large portion of the nucleotides that form the DNA and RNA. We are still going to get to that when it comes to we have 4 biomolecules basically: carbohydrates, lipids, proteins, and then nucleic acids. When we get to nucleic acid, you actually find out that the there is a sugar component in the structure. There is a sugar component. Usually it's a 5-membered or 5-carbon like sugar component, which is like ribose or deoxyribose. The only split difference is that one lacks an oxygen. So like deoxyribose is just a deoxygenated, like one oxygen has been removed from the ribose basically, and this forms the glucose the sugar portion of the nucleic acid. The nucleic acid is made up of 3 components: the sugar component, the phosphate component, and then those bases, those nitrogen bases. So those 3 things form the nucleic acid. We'll get to that. We're still in carbohydrates for today, but just know that the structure of the DNA that forms and that carries genetic material from one generation to the next progeny is part of it is formed by carbohydrates too, ribose and deoxyribose. The next thing we have, carbohydrates play a role in lubrication, cellular intercommunication, and immunity. Usually, a lot of like antibodies, and also a lot of like messengers in the body too, in the cell, from cell to cell, are carried on carbohydrates. And then carbohydrates also play a role in the metabolism of proteins and fatty acids. Metabolism involves the build-up and the breakdown. So also in the build-up of proteins and amino acids, proteins and fatty acids, carbohydrates are important, especially in a process that is called gluconeogenesis, when you use glucose to make other biomolecules that are not carbohydrates, like proteins and fatty acids. So like with this, you can see like carbohydrates are literally used from head to toes, like from the top to the bottom of any living organism. So that's the reason why like it is the most common, it is the most abundant. I wouldn't say it is the most useful, but it is really, really like important. A major highlight is on the fact that it is used for as the primary energy source for living organisms, whether plants, animals, or microorganisms. So now we're done with like the introduction on the function. We'll now go next to the classification. And inside this classification, we will now discuss the structure. So that way, you get both the function and the structure.